Hey there, or very few people. So this lecture 1.5, we kind of got squeezed for time in lectures. So this one's being recorded after the fact. So for those not watching it live, this one was in fact recorded after 1.6. Not that that's going to make a huge difference, but this is a pretty critical topic to starting to make sense of the earlier labs in the course and also just getting a head start on the project. It's a topic around testing. In particular, the testing part of the software development lifecycle. Now, in most other parts of the SDLC, when we talk about it, usually we go into some kind of theory about, in design, it's like, why does design matter? And in requirements, it's like, why do requirements matter? And what is deployment? But testing, at least at the start of the course, we do talk about it a bit more, but this is more an introduction to just testing with Python. Yeah. And because of that, we are just today going to be focused on how do you write some Python code and how do you write some tests to make sure that that Python code works. So a little bit of an introduction with testing first. I think a bunch of students have told me that they no longer teach asserts in 1511, so this code could be slightly confusing, but basically assert in C, this is a piece of C code here, is a function that when you run it, it takes a condition, and if that condition is truthy, as in if it evaluates to true, then nothing happens, the normal program flow continues. But if the result is falsy, as in the condition is not true, then the program crashes. So it's a very helpful way to do some debugging because they're kind of like sanity checks throughout the code, right? And that's all testing really is. It's just you setting expectations, really. In C, this is a pretty simple piece of code. It's a function that sums up two numbers. You then can run a main function that just checks if that sum function works. And it does that by checking if the sum of 1 and 2 is 3, if the sum of 2 and 2 is 4, if the sum of 3 and 2 is 5, etc. We can do a very similar thing in Python. And the first step is to actually, just have a quick look at the functions. As we talked about in lecture 1.4, Python functions are a lot more simplified than C functions. Very similar, except obviously the Python syntax, there's colon, not braces, and also there's no types. So in C, obviously you have double return and double parameters. And I just mentioned that. So how do we actually test a function in Python? So let's pull up VLab. Now what I might do just for this lecture, just for fun, is let's do this one in VS Code, just so people can have a little bit of a play around with VS Code. So remember that I opened this by typing in code, and then I did a dot after code, which is my way of saying I would like to open VS Code in this window, right? Like in this directory. If I just type code, it just is going to open VS Code as it last was opened, which in this case will be the same files. But when I say code dot, it's kind of like saying dot slash, which is saying please open VS Code where the directory is week 1, and therefore I can see all my files. Yeah, let's do a really basic pytest. Let's do something super basic. So we'll start off with no, sorry, that's the wrong code example. We'll start off here. We have this really simple sum function. It's a function that takes in x and y and it returns the product of x and y. Now obviously this is broken because that's not what a sum function should do, right? A sum function should be sorry, I'm just getting to this folder again. CD1531 week 1 content lecture code week 1. Yeah, so obviously if I run this code, it's not going to do anything. Python 3, test 1, no pytest. It will just do nothing because it's not actually printing anything or anything. And if I try and print sum of 4 and 5, I'm going to get not 9, I'm going to get 20. So if we want to test this, how would we do this? Well, kind of the C style way to do it is that you might write a test function, like test sum, and what that function does is it does a few asserts, and maybe it will assert that we expect the sum of 1 and 2 to be 3, we expect the sum of 3 and 4 to be 7, we expect the sum of 10 and 10 to be 20. And so we've got our test function there. Now when I run that, you notice that it still outputs nothing, and it outputs nothing because there's no like main function, like it's just functions, right? If you have a C file that's just functions and no main function, it won't print anything. So now if I want to actually use that, I have to call test sum explicitly. And you can see I get an assertion error. So assert in Python is built into the language. You don't need to import anything. And in this case, my code has failed because it's like, I ran this assert, but it wasn't true. And it actually tells you what happened. Yeah, it tells you that it failed on line 5. And it said that it expected sum of 1 and 2 to be 3. So this is why testing is useful, because often the plan is that you write tests before you actually write the code, and therefore when you write your code, your implementation, you are able to benchmark it against these tests. If I want to change this sum function, I could make it sum of x plus y, and now it would pass all the tests. And because all of the asserts were true, it does not fail, right? It just keeps going through the code. Excellent. So that's how it fails. Now, this is all well and good. Yeah, I kind of just skipped a few steps here. This is an analogous example. This is like C-style testing. This is what at least students fairly recently and for a long time would have done in 1511. And if any of you have done 2521, it's what you would have done in 2521 as well. But the problem with that is it's just not very elegant. Like if you want to add more test functions, you have to kind of add another test function. Like, you have to add test sum 2, and then you have to call test sum 2 as well, like this. And then it just kind of, it's just more to write. So we need a more automated, scalable way to do this. And this is where pytest, which is a Python library, comes in for us. Pytest is a library that you can look up. The link in the lecture slides take you to a really great resource, which is, the pytest website, where it can help you with like examples. You can honestly like waste hours on this. Asserting with the assert statement, right? We do some basic things in the lecture, but you can go and learn more. But let's actually have a look at what pytest does. So, what is pytest? Pytest is a library that helps us write small tests, but can also be used to write larger and more complex tests. Great. Pytest comes with a binary that we run on command line. So what that means is it's kind of like it can be a separate program, just like Python, Git, GCC. These are all command line programs. And the way pytest works is it looks through an entire folder full of files for files that have certain names, and then in those files it looks for functions with certain names and it processes them all. So basically, if we have 5 test files and each test file has 5 functions in it that are test functions, if we name them correctly, pytest will go and it will find all of them and it will execute all of them. So it's a great automated way to actually run these tests. Now, I just talked through this example, this no pytest example here, and we ran that, and we showed that you can assert a sum that way. However, let us have a look at a proper pytest example. We don't need this import pytest. I think that's a mistake that I put that there by accident. But notice this one. If we just run this code by itself, python 3 test2 pytest, nothing happens because there's no main function. We just kind of established that before. However, what happens if I run this instead of with Python 3, but with pytest instead? I have to give it the right file. Let me do this one in terminal. This is one thing I really struggle with. Sometimes I don't love. Maybe we'll just make this bigger and make the terminal. Nope, that's not the right. That's not the right command. How do we make this go up to the? Oh Lord. See, we're all learning here today. This is where the live streams are useful, because normally someone just tells you that you're doing it wrong. Appearance, centered layout, I don't know. Figure it out. Editor layout, split, 2 columns. Okay, now I just want to take that and put this up here. Damn. Alright. That's okay. Let's just go. Someone will tell me, someone's watching this laughing at me right now. Let's just have a look over here. So if I just run pytest test2 pytest, have a look at what the output is, right? There's a whole bunch of fluff, and then it tells me the function, it tells me the file that it ran. It ran my test2 pytest file, and it tells me the functions that it ran inside my file when there's failures. So in this case, it's saying the test2 pytest file, I should point this way, has failed, and the reason for the failure is the test_sum1 function has failed because there was an assertion error where it expected 1 plus 2 to be equal to 3, and it wasn't equal to 3. So notice the difference here again between me running Python 3 test2, which does nothing because there's no main function, and me running pytest test2 pytest. So this one will go through the files I specified. Now if I don't specify any files, what it will do is it will, let's have a look, it will go through my folder that I'm in currently, and it will look for any file that starts with test underscore. So you notice how it ran this random file that we haven't looked at called testmultiple.py. That's because testmultiple.py starts with test underscore, right? So pytest, if I don't give it any files, will just look for anything like that. And in fact, watch what happens when I rename this from test2 pytest to just test pytest. When I run pytest in this folder again, you can see, runs both files because it just went and looked for all of the test underscore files, and this is what it found. You can see that test multiple passed, but test pytest failed, and it's giving us those issues there. If I do another couple of functions, let's have a look at this. VLab's frozen, or VS Code's frozen. VS Code, what are you doing? Oh, great. Okay, so I imagine I have 3 sum functions, right? And they're all slightly different. Like this. Now, sum1, sum2, sum3, when I run pytest, they will all, they will all fail. It'll find the 2 files, and all 3 will fail because all 3 functions have asserts in them that don't pass. Right? Remember again, assert is just a function. In this case, you see we've written it without the brackets, which is just shorthand, but either's fine. Assert is just a function that takes a condition, and if it is a falsy condition, it will crash the program. In the case of pytest, it will fail the test. So, what do you notice about this up here? Notice how that test multiple has 3 green dots and test pytest has 3 red Fs. So that's because for every function in your file, pytest will report on how that function went. So if we had 3 of our functions pass, it would give us 3 green dots. But in this case, it's given us 3 red Fs. Now, if I fix up my file so that I actually do a plus here, what you'll notice now is that we get 3 green dots, which is good because we've succeeded, right? And this is how you can kind of work on your code where you write lots of tests to make sure stuff works, and then you're able to run it against your code and modify your code until you pass stuff. So this is kind of testing 101. You tend to have these automated tests that run, because here's how I kind of describe it. If you have to intervene with your tests, like if you're testing in another course as like printing out printfs that say test succeeded, or gives you the values that you have to manually check, then that's not really testing, that's just you debugging. Testing in itself nearly needs to be automated, because if it's not automated, then it's not going to be scalable, because you can't have a 10,000 line project and then run printfs every time you want to see if it works. So we need these kinds of automated systems where if we want to see if our code is still working, we just run pytest. It runs all of our tests for us, and then we know if we've succeeded or not. There's another test file I have which we'll look at, which is this test multiple file that we saw before. This is just showing you how you might more realistically write tests. So if I have a sum function, x plus y, then I might have 3 test functions here. And the first test function is called test small, which just tests the sum of small numbers. The second test function is called test negative, small negative, which is small negative numbers. And the third one is test large, which tests large negative numbers. Now, what I want you to take away from this example is it's really bad practice to do something like sum1, sum2, sum3. You really want to have your functions named something meaningful. Because if they're not named something meaningful, then it's impossible for... So it's really hard to read, right? Like, what's the point of even splitting it up? So when you design tests, generally what you do is within one function, you'll have many asserts that are all testing the same general theme. In this first case here, it's small numbers. I am testing, where is it on the screen? Up here. Yeah, I'm like testing small numbers. In the second case, I'm testing small negative numbers, even though those numbers are different. And in the third case, I'm testing large numbers. Now, we usually want to break things up into multiple functions, because the way pytest works is it doesn't report to you based on a per assert basis. It reports to you based on a per function basis. So you'll see here that when I ran test multiple.py, I got 3 dots because there's 3 functions. Even though there's 9 asserts, there's only 3 functions. So we like to break things up into functions because it helps us granulate our work, right? So when we get told we fail, we know a bit more about where we failed. I touched on this a bit earlier than originally intended, but normally when we introduce pytest, we say if you want to run all of the tests in a file, you type in pytest and then the name of that file, like test multiple, and that will run that file. As I said before, if you just type pytest, what it will do is it will go into that folder and all subsequent folders, and it will look for any file that starts with test underscore or it ends with underscore test.py. So similarly, I could rename my test underscore pytest to pytest underscore test, and pytest will also find it. Right? So that's the 2 patterns that it looks for by default. That's just how pytest is designed. In general, in this course, we don't mind whether you do test underscore or underscore test. So that's how pytest looks for the files. And then within each file, it looks for functions that start with underscore test. So notice here how I just renamed this test file from test small to small test. And you see, compared to the previous run, pytest only ran 2 tests instead of 3. And that's because of the change in the file name. So while the files that contain the test can start or end with test, the actual functions in the test file need to start with test underscore. That's again just how pytest is designed. So there's a lot to pytest. What I've shown you is like the absolute basics of the basics, and in a lot of ways, the basics of the basics are really all that you need for this course, right? You don't need anything like crazy complicated. Um, so, what we're going to do is touch on a couple of the more interesting parts, such as, again, this is just a couple of samples of what the pytest library can do. One of them you can see here is that if you want to run a specific function without running the rest of the test file, you can typically, you can typically give it like a keyword. I'm not sure what the -k stands for, but like for instance here, when I say pytest -k and then small, what I'm saying to it is, okay, go and find all of the pytest files that are relevant for you, but inside of that, I only want you to actually test on the files that have like small in the title, right? So if I was to then run this, what would I get? You can see that it only ran 2 tests because it matched these 2. And pytest also reports to you that 2 tests have passed and 4 were deselected. And what it means by deselected is that it found 3 tests in multiple, in test multiple, the other file, and it found 1 test in our, it found 3 tests in pytest test and 1 test in test multiple that did not have small in it. So that's why they were deselected and they didn't run. There's also a whole bunch of what are called markers in pytest. These use what are called decorators, which we're going to chat about later in the course. They are those funny little @ things above functions. You just have to understand them at face value for now, but we will talk more about them later. To use any of these fancy markers, you have to import pytest into your file. So you see here how in test multiple I've imported pytest. You don't need that pytest library to actually run your tests. All you need that library for is when you want to use pytest markers or something fancy. So for instance, with test small negative here, I've got a bunch of example markers in here. I might use pytest mark skip. Like that. Now let's run it. Now let's see what happens. I'm going to run test multiple specifically this file, and you see the output, it did .s . And that's because it's saying that one of them passed, one of them was skipped, and then one of them passed, and that's because this one was skipped. I haven't found a strong use for this myself much, but generally this is handy if you kind of want to temporarily disable a test, instead of commenting it out. And you might ask, why would I not just comment it out if I don't want it to run? What's useful about not commenting it out is that the Python interpreter will still actually check, I believe, if this is valid syntax. So for instance, if you just go like blah blah, I think it'll fail. Yeah. So this is really useful because even though the test isn't run, the Python interpreter will still actually check if your code is valid. Whereas if you had problems in your code and you commented this out, then it wouldn't notice it, obviously. It's complaining here because of this pytest skip. So yeah, now it'll just be like, yeah, seems fine. One sec. I can't code. Yeah. So that's why we like pytest skip, because the syntax is still actually interpreted, which is really helpful. There's pytest xfail. I can't remember what xfail is off the top of my head. I don't expect you to either. So when you have these questions, you can just Google them. Xfail pytest. And we usually, first few links in Google will usually give you an answer. What was it called? Xfail? Mark test functions as expected to fail. Okay. So this is how you can say that you expect something to fail. So normally by default, a test function in pytest is assumed to succeed. Because you don't want anything to fail in it, right? If something in the test fails, then the test fails. But if you say xfail, it's saying I expect this to fail. Oh god, one sec. And therefore, when you run it, pytest 1x passed. Does that even make sense? Surely that should say that it expected it to fail. I don't know why it says pass. I don't really use this function much. X passed means unexpectedly passing. Okay, so I mean this is a great example of where the docs and stuff are really useful too. Like that didn't take me long to understand what it was. It said this test will run, but there'll be no traceback when it fails. It said if it unexpectedly passed, then it will tell me X passed. So this is kind of useful because now I could write some tests if I wanted to that I could mark as I expect this one to fail. And if it passes, then I get notified of it here. Again, I haven't really found a use case for this in my limited interactions, so I wouldn't stress too much about that. We got two more. One is mark up and mark down. I mark up. Let's see what this one does. Bit of a mystery. Mark up. Is this a typo? You can register custom marks to avoid this warning. Well, let's have a look at what mark does. So let's see. PyTest mark up. Working with custom markers. Blah, 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 blah. This one isn't. I remember working with these. I mean, these are not really meant to be worked through. I think I'm just relaxed because we're not in a lecture time. But the point of these ones, I again don't really think you need to use any of those. Is you can have quite a broad reach of what you want to do, and I think fixture is the one I really want to focus on, because fixtures will have a huge impact on you in your first iteration. Now, something that happens in your project a lot, and I'm just going to speak in a very simple example here, is that you will often... Oh, why is it frozen again? I don't like VS Code. Damn it. So, the one that really matters is this pytest fixture, because you'll use it a lot in your project. Now, what fixture does is, let's say that I have some code that I want to use in all of my functions, right? And I'm just going to give you a very loose example here, because obviously this example is a bit too simple for it. Is I might say, all right, well, in every one of my functions, I want to have like a point, which is like, you know, my point equals 1 and 2, like this. And I want to check if point 0 plus, like if the sum of point 0 and point 1 is equal to 3. Right, and let's say I also want to do that in this next function. It's a little bit silly because obviously you wouldn't want to test the exact same thing twice. But the point is, in many functions in iteration 1, you will always want to do the same kind of setup at the start of the function, like create something. And it's not really good practice to kind of copy and paste code. So the easy way to do this, which is very pytest, is you create a pytest fixture. And the way a pytest fixture works is that, think of it like a function, which in this case I'll just make it this. I'll have it be a point that just returns point. And how a fixture works is that all you have to do is when you create a test function, like a pytest function, you notice that all our pytests so far don't take any arguments, like the parameters are always 0. I just pass that point in like this, supply point. And supply point here ends up becoming the variable. So if this makes sense, and we'll just talk through this example a little bit more. Can I zoom in a little bit on this? Yeah, we can. Okay, good. So chunky. Now when I run this, oh, unindent, what have I done? Some tab problem. Careful of tabs, dangerous tabs. Notice this still passes. So what I've been able to do here today is have two different tests use the same setup data, basically like operate off the same you know, variable, like whatever the hell I want. It could be a series of variables. And that's very, very useful because it means that, you know, in your project, you're often going to want to have like 10 different, you know, 10 different files or something that all 10 different functions, I should say, sorry, that all kind of need the same setup. They all need to establish the same variables at the start. So you can use fixtures, and it's one of the easiest way to get design marks for iteration 1 as well. You can read more about pytest on their website. Their website is very accurate, very detailed, though a little bit hard to read because it's quite dense. There's a great little tutorial here on Guru99 that I've linked, which can, kind of get you familiar with some of the basics of pytest. So that's a good place to start if you're feeling a little bit overwhelmed. Now, just to tie this lecture off, I want to very quickly talk about the project in terms of like pytest in the project. So what I'm going to do, this is my copy of the project, not yours. I'm going to clone the project for me here. I'm going to git clone project backend. So imagine this is my team's project. And let's have a look at the files in here together. So I'm inside project code dot. Okay. Now you can see that inside the project, by the way, if you haven't seen 1.6 yet, the lecture, I would suggest you pause this right now and go and watch 1.6, like the intro to the iteration lecture, and then come back to this point, because I think it'll be better to understand the project just a tiny bit more when you're making sense of this. So you've got these two folders, which are source and test. And inside source is all these different functions here that had been stubbed for you. So what that means is that, we've given you the basic parameters and the return types, but it's all fake data. It doesn't really do anything. If you imagine like, it's like, what's a good example? It's like a wireless router. It's a terrible example. It's like, you get a little wireless router. It has a little light on the front telling you it's on. It's like a stub function is like a wireless router with just a little LED on the front, but inside it's completely hollow. It's just there to look like it's finished, even though nothing is actually done about it on the inside. So what it means is that someone can call one of these functions in your project, and they will get some data, and at face value it looks like they're getting something meaningful, but in reality it's just some hard-coded data. So what I want to point you to in your project is there are these two files that I've made for you called echo and echo test, right? And great. How do I split things? Split down. Great. Echo test. I already have that file. So pay attention to these two different tests. Two different files. The first one is echo. And what echo does, it's a very straightforward function. It checks if the parameter that's passed, the argument that's passed in is the string echo. And if it is, it throws an error. And if it's not, it returns the value. So basically, it's a function called echo that it expects to get the, it expects to get a value, and all it does is returns that value. And if you give it echo the string, it craps its pants. Now there's a couple of things here, like what the hell is this import statement? What the hell is this exception raise input error? This is all stuff we're going to be talking about next week, so you can kind of ignore it a bit for now. But let's just try and use this, right? So if I say, if I try and print echo Hayden, let's see what it does. So I'm going to go Python 3 source/echo, because that's where the file is. It's in the source folder /echo. And it prints out Hayden. If I print out my last name, I get my last name. If I pass in echo, it's going to be like, grr, failed. And that's what the function does. So how do we actually test that function? Well, inside of another file in our test folder, we have a it's called _test, so that our pytest knows to run it. And then inside that I have a function called test _echo. And then what this does is it asserts that echo of 1 is equal to 1 and that echo of ABC is equal to ABC. By the way, you can ignore these little strings at the end. They're just there for like show. Think of them like comments. They're not critical. And echo Trump equals Trump. And then you'll notice that there's a third thing which we're going to be talking about next week, which is how you actually check in the cases it fails. So this first test is to test to make sure that it succeeds where we expect it to succeed. And the second one here is to make sure that it fails where we expect it to fail. So what that means is that for your project, for iteration 1, what you're really doing is essentially implementing a couple of these files, you're implementing these functions, and then you're writing tests for them. And you can actually use what you see in Echo as like a bit of a base, a bit of an example. So everything you're doing in iteration 1 is essentially just substantially more complicated versions of what's happening in source/echo here, and what's happening in test/echo test. So you just need to come along and make a whole bunch of test files and actually start testing your what you're writing. Now, if you go have a look at the project backend specification, what you'll notice in part of iteration 1, and again, this was talked about first in 1.6. Sorry about the confusing order of things, but oh, my camera's gone. That's okay. I could probably turn the other one on. Give me a sec. Camera. Where is it? Window capture? Display capture? Video capture device? Ugh. Yeah, this is a... Hello. Ugh. Giant. Okay, we'll just hide me over here. As part of iteration 1, you're basically... like we talked about this in 1.6, but it's like you are writing tests and functionality for the stuff we just mentioned. You're just implementing those source and test folders. You're also going to be writing down any assumptions you come across. So read this part of the spec in like a text file, and we expect you to follow the right Git practices and teamwork practices that we're talking about on Monday. 3.2 is kind of the one that is quite relevant to this testing piece. And again, we will talk about this more next lecture, but we want you to approach the project in a really specific way. And what we mean by that is that if you look at these steps here, we ask you to do some things like create a branch and all this stuff. Now on Mondays when we talk about branches and merge requests, but the crux of this 3.2 section is we're asking you to pick a small feature, maybe like register or login or creating a channel or updating a user. Pick a particular feature, and it can be a couple of functions. It doesn't have to be one function. And we want you to write tests for that feature and then commit those tests. So if I was writing the echo feature, then what I would do on my machine is I would first write echo test. I would write these test functions. I would save it in a file called echo test. I would commit that file to the repo. And then after that, if you read the instructions, it says you write the test first and then you implement the feature, right? So you write then the code for the source part, right? Because source is the implementation. So I'd write the code for echo and then I would run pytest. You know, I'd go here and I'd be like, okay, I've done my code, so I'm gonna, I'll run pytest on source/echo test. Oops. Sorry. I run pytest on source/test. Wait, is it? Oh, sorry, test on test/echo test. Pytest on. I can't get it right. What is it? Tests. Okay, sorry. Pytest on tests/echo test, and then it will tell me that I've passed. And once I've passed, I then will commit those changes. Right, so again, Monday we talk a little bit more about the Git side of this, like how to make a branch and then merge it back. So we'll loop back to this example. But from a basic testing functionality, forgetting Git for a second, the point is that with this iteration, we expect you to write tests, commit tests, write the implementation, use your test to make sure you're correct, and then commit your implementation. This is what we call test-driven development. And it's the process where you do a little bit of testing and you write your code to make sure it works. You do a bit more testing and you write your code to make sure it works. It's one of the most basic, decent software engineering principles. So that should hopefully give you a little bit of a head start. Other than that, as I mentioned in the other lecture, please just make sure you spend this week getting familiar with your group and chill out. All you have to do, lab 1 this week, right? Go to your tute, finish lab 1, and week 2, we'll get stuck into it all in week 2. Okay, so anyway, thanks for the 3 people who've been here on the live stream, and have a great weekend, because this is our last lecture for next week. If you need anything else, just post on the forum.